Hi, I'm Zack from Kid2Kid Tutorials, and right now we're going to be talking about the squares of binomials. So for our first problem we have, if x equals the square root of 6 over 7, then evaluate x plus 1 over x squared. So we've already written everything out because the takes took forever, and I'm just going to walk you through the steps of how we did it. So the formula for this, if you have something like that, so a equals x in this case, and b equals 1 over x. And if that's squared, then there's a formula for that. So if you have a plus b squared equals a squared plus 2 times ab, 2 times a times b, or 2 times ab, plus b squared. So a equals x and b equals 1 over x. So we plug those in. So x plus 1 over x squared equals x. So as we have here, a equals x. So x squared plus 2 times x, a is x, and b is 1 over x. So x times 1 over x plus 1 over x squared. b is 1 over x, so that's squared. So now we factor all those out, or simplify all those out, and we get x, and we get x squared plus 2 times, so x times 1 over x is 1, and 2 times 1 is, just kidding now, it's 2. So 2 times 1 is 2, and 1 over x squared is 1 squared, which is 1, over x squared, which is x squared. So we have x squared plus 2 plus 1 over x squared. So now we can substitute the square root of 6 over 7 in. And if we substitute this in before, then that would take a whole lot of time. So I'm going to be lazy and just do this shortcut. So we have the square root of 6 over 7 squared. So if you have something like that, a square root of 6 over 7, this is called a radical. And this is squared. So if you have a radical and that's squared, and something inside it and that's squared, then the radical cancels out, and so does the squared, the power of 2. So we can just write it out as 6 over 7 now. So 6 over 7 plus 2, and 1, the same thing applies here. 1 over 6 over 7. So we're left with 6 over 7 plus 2 plus 1 over 6 over 7. So I know this part looks confusing, but we have a way to break it out. So 6 over 7 plus 2 plus 1 over 1. I like writing it like that because it's a fraction, and I like a denominator underneath it. So 1 over 1 is just the same thing as 1. So 1 over 1 divided by 6 over 7. So that's the same thing as 1 divided by 6 over 7. So 1 over 6 over 7 is the same thing as that. So there's a trick to doing this. If we have these divided by each other, we just flip the second one over, which is called a reciprocal. So the reciprocal of 6 over 7, or 6 over 7 flipped around, is 7 over 6. So now we have 1 over 1. And when we flip the second fraction, we change the division sign into a multiplication sign. So we have 1 over 1, or 1, times 7 over 6, which is 7 over 6. So 6 over 7 plus 2 plus 7 over 6 is what we have left. So now we find a common denominator for these fractions. So 6 over 7 plus 2 over 1, or just 2, plus 7 over 6. So the common denominator, how you find that is multiply the highest. So multiply 7 times 6, which is 42, and 1 goes into 42, so we can have that as a denominator. So we need to turn 6 over 7 into make the denominator 42, we need to multiply by 6. So whatever we do to the denominator, we also do to the numerator. So 6 times 6 is 36 over 6 times 7 is 42. Plus, so we need to multiply 42 to make the denominator 42. So 42 times 2 is 84, divided by 42 times 1, which is 42. Plus, 7 times 6 is 42, and 7 times 7 is 49. And if we add all those up, 36 plus 84 is 120, and 120 plus 49 is 169. And we don't need to add the denominators. So we're left with 169 divided by 42. Final problem. Expand the product a x plus y cubed or to the power of 3, and I'll let you read the rest. So we have x plus y cubed or to the power of 3, and that's the same thing as parentheses x plus y times parentheses x plus y times parentheses x plus y. So you can also write that out as x plus y times x plus y squared. And let's solve, well, x plus y parentheses squared. Sorry, my bad. So we can solve x plus y squared first. So that is x squared plus xy plus xy or yx. So x squared plus xy plus xy or yx plus y squared. Well, there's another xy. So, so we have that. And x plus y plus x plus y is 2xy. So we have x squared plus 2xy plus y squared. And we have that, and we multiply that by this to finish the expression. So times that. We can do the variables one at a time. So we'll do the x first. So x times x squared is x to the third, and x times 2xy is 2x squared y, plus xy squared. X times y squared is xy squared. Now we do the same thing for y, which is y times x squared is x squared y, and y times 2xy is 2xy squared, and plus y times y to the third. Y times y squared times y is y to the third. So now we can add these two expressions. So let's find the like terms. So 2xy and x. So first we have x squared y and 2x squared y. And if we add those, we get x to the third and x squared y plus 2x squared y is 3x squared y. So now plus, and other like terms are 2xy squared and xy squared. So if we add those, we get 3xy squared. And since y to the third doesn't have any like terms, we just leave it as that. And we get this as we simplify x plus y cubed. And if you've done the rest, it would look like that. So x to the third, x to the fourth, x to the fifth, x to the sixth, and then y to the third, y to the fourth, y to the fifth, y to the sixth. And if you just And if you look at it closely, you can see Pascal's triangle. And Pascal's triangle is just like 1, and then you add a 1 all the way over here, 1 all the way over here, and these 2 is 2. If you add these 2 ones, that's 2. And 1 plus 2 is 3, 1 plus 2 is 3, and then you just keep doing the same thing. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then you keep adding a 1 in front of it and at the end of it. So you can see a pattern from Pascal's triangle, and up there it's just like Pascal's triangle but with variables. Thank you for watching Kid2Kid Tutorials, and if you like our videos, please share, like, and subscribe. And also, happy Mother's Day to all the mothers around the world.